we'll take our look at the calendar. Today we talk about two things, polynomial models, i.e. word problems, and polynomial regression. We've already talked a bunch about linear regression. Today we extend that idea to some curvy things. And then, yeah, that's what's coming up. Next class, what's going on? Quiz. Quiz number 8 is on Friday. And then a look at the GCC calendar. If you were planning on withdrawing from a class, I hope you did it because yesterday was the last day to do it. This coming Friday, 2 days from now, follows a Monday schedule during the day. So this Friday, you go to your Monday classes. It won't affect us, but it might affect some of your other classes. The goal is to make it so that every semester there's an equal number of Mondays, Tuesdays, Wednesdays, etc. And there must have been a Monday off, yeah, the Patriots Day that's coming up. So this coming Monday is a day off. We have no classes Monday. Yeah, and so this is the one to make up for that. Anybody have a Friday evening class? Nope, they are on as scheduled. Anybody have a Monday evening class? You go to your Monday class. Monday evening classes are still on. Day classes are canceled, okay? All right, so let's take a look on page 29. Here in the middle, we'll start with number 1. Can we go to Katrina? Okay, so one of the homework assignments for tonight is going to be about models, word problems. And so I just want to do one of them right now, just to give you a sense of what they might look like. So we'll try number 2, Brian. Okay, so let's see if we can draw a picture of this kind of a thing. So probably you've seen it before. It says we have a rectangle. What does surmounted by mean? On top, surmounted by a semicircle. So right on top of this rectangle is a semicircle. And I'll go ahead and put a dotted thing in there. It's just one solid window. Maybe there's some framing or stuff that's happening, but that's what the window looks like, okay? All window, rectangle, on top of it is a semicircle. You guys have seen windows like this before, I'm sure. Okay, so here's the idea. The perimeter of this window is supposed to be 30 feet. This is a big window. And could you guys imagine, there are a lot of different kinds of windows you could make if you had 30 feet of edging to use. Like, forget about the fact that making the different glass sizes is challenging, but you have 30 feet to use all around the edge. You could make it so that the, maybe you can make it so that it's kind of like a wide rectangle, so you don't use very much stuff there, but then what happens with your semicircle if it's long and short here? It's going to be like a big semicircle, right? So maybe most of your edging is on the semicircle. Or maybe you could say, well, I like a really, really, really tall, thin window. But then what happens with your semicircle? It's just a really tiny thing. But either way, you have 30 feet all the way around, okay? And of all these different kinds of windows you could make that all use exactly 30 feet, do you know what we're going to try to do? What's that, Eliza? We are going to make an equation. What do you think we might try to accomplish? What's that, Derek? Okay, so we got lots of different sizes of window. Out of all of these windows, maybe there's some maximum or minimum thing we can find. And it feels like area is a natural thing to look at. We want as much light coming in as possible, maybe. So how about we try to make this window as big as possible, meaning area. Let's make the area of all these windows as big as we can. Let's pick the winner out of all these infinitely many choices that we have here, okay? So that's the goal. And let's see if we can't make progress towards that goal. So the first thing we're going to do is start labeling the sides here. So what would be a good name for the like the width of the window? Okay, so H for height, we'll do that. And how about the bottom side? Okay, we can call that L for length. That's fine. Yeah, and so Eliza's pointing out something important here, that the circle has an awful lot to do with L. The circle has this diameter that's exactly the same as L. Okay, given that we're thinking about measuring all the way around, What circle word talks about how far you walk around? It's circumference, right? You guys remember the formula for the circumference? Is that right? Circumference is pi r. What do you say, Joe? Pi times 2 times r. Yeah, we've got both formulas that are important up here. One is circumference, one is area. I always had a hard time remembering which one was which until I realized that area is how many dimensions? Area is a two-dimensional thing, right? You see up there the r times r. That is taking a single r and multiplying it by another r. 2 dimensions. How many dimensions are in the bottom number? How many r's do you see? Just the one. Circumference is a one-dimensional thing. Okay, so let's not use the pi r squared yet. Circumference is 2 times pi times r. Which means maybe instead of L, we could use a different letter over here. So how about we don't call this L? How about we decide we're just going to go from the middle of this thing to the edge to talk about a radius. So the middle of my circle to the edge, what letter could we use there? Let's use an R. And now I feel like I have too many letters. I have more than I need. I have 3 letters up here. But L is very much related to one of the other letters. What is L really? It's really 2R. You buy that? L is an R plus another R. Okay, no more L. That's now 2R. Fewer variables is better. Yes, that's what we're going to do. Because we have only a semicircle, so this circumference is the whole circle. So we'll end up dividing it by 2. That's right. Okay, let's see if we can figure out this business with the perimeter is 30. Perimeter equals. Let's do the straight sides first. How many H's do you have? I have 2 H's. What about the bottom side here? That's 2R. Those 2's are kind of different. You have 2 H's, literally you have 2 vertical sides. The bottom is the only horizontal side you have, but it happens to be double something. It's 2R. Plus, then what do we still have to account for? Is that semicircle, the half the circumference. Yeah, so the circumference, the whole circle all the way around is 2 pi r. We have only half of a circle, so you guys believe that's the perimeter of half of a circle. It's just pi r, not 2 pi r. Okay, we are given a number. What is this equal to? It's definitely equal to 30 in this problem. Michael. Okay. So this perimeter is 30. And there's not much we can do with that at the moment. We'll just let it sit there. Now we're going to come to the actual problem here, which says find a function that models the area. So we need a formula for the area of that whole window. Now the window has 2 different pieces. There's a rectangle part and a semicircle part. So somebody we haven't heard from yet today, what is the area of the rectangle part? Yeah, it's a length times a height. So use the letters that we have here. H times 2R, right? That's the area of the rectangle. Length times width, or H times 2R. So H times 2R. That's the rectangle part. Plus, we need the semicircle part at the top. All right, I feel like we need another formula for my circle. We had it here before, but it was mislabeled. What's the formula for the area? Somebody we haven't heard from yet? Thank you, Andy. Pi r squared. That's the area of a full circle. So what's the area of my top part up there? It's half of that. You see it? Half pi r squared. Okay, that right there is a formula for the area. How many variables are on the right-hand side? 2. I have h and I have r. That's unfortunate. I can't type it into my y equals because I'm only allowed to type in a single x. So the goal is to get rid of one of those letters. Do you see some information we haven't used yet? Is that 30 equation? What do you think we're going to do in English? You have that 30 equation, which we haven't used. Yeah, maybe we're going to solve this 30 equation for either h or r. And once we know what h, and then we substitute. Right? That's something we've done before. Maybe not in this context, but that's a reasonable thing to try. Solve the first equation for h or r, plug it into the second equation. Okay, the first equation. Does it seem easier to solve for h or r? How many h's do you see in that equation? 1. How many r's do you see? 2. Sure feels like it's easier to solve for the thing that there's only one of. So let's solve that equation for h. So I'm kind of ignoring this part over here. Don't worry about that. It's just that equation. Solve for h. First thing we need to do is get the 2r and the pi r over to the right. So this is now solve for h. So I've got 2h equals, how do I move those terms to the right? Subtract. So we used to have 30, and then we have, everybody see that? Subtract the 2r, subtract the pi r. Again, the goal was to solve for h. What do we do? Divide everything by 2. So h equals 30 minus 2r minus pi r, all divide by 2. So far, so good. And the goal was to take that h and do what with it? Was to substitute, plug it back into that red equation for h. It's going to get messy. That's okay. We can handle messy. All we have to do is carefully write it down. Area equals. Instead of the h, we're putting that whole thing that we just found in green. And what happens after the h? We're not up to the pi r squared yet. Times the 2r, right? We're copying everything. And then plus the half pi r squared. Okay, you could do some algebra to clean that up. I'm just going to do one thing, and that's cross off these 2's. And I'm just going to leave it there. It could get a little bit nicer, but I think we've accomplished our goal, which was to find a formula for the area, which has how many letters on the right? Just 1. Lots of r's. Much better than what it used to say here in the first red equation. How many letters were in there? 2, h and r. Now it's better. Now I can type it into my calculator. So I'm just going to do this real quick. You don't need to type this in, but let's see if we can't get to the conclusion here. So we've got, I'm just trying to type in this thing in red here. Y equals, parentheses, 30 minus 2 what? I don't have r. 2x minus pi x, parentheses, times x. And we canceled the 2's, and then plus half 0.5 pi x squared. There it is. And then I'm going to look at the window, really think about what I'm doing here. I don't have x. What was the letter in our problem? It was r. What's the smallest r that makes sense? Probably 0, so we'll start at 0. It's okay to say R can't be 0. You could say R is at least, you know, like 0.0001 or something, but we'll just call it 0 and know that that won't be the answer. I don't really know how big R can get. Would it be more than 30? Let's see. I mean, if your radius here was 30, then what do you think about the amount of stuff on the circle? Yeah, perimeter can't be more than 30. So like if this is, yeah, so what if that's a 15? What do you think about the perimeter? More or less than 30? If that's 15, the radius, then what about that perimeter? Is that more or less than 30? It's more, because if that's a 15, and so is that, and this is further than the straight line. So I can't even go up to 15 on the R. You could find out exactly how far you can go, but we'll just call it 15, it's fine. But definitely can't go forever. And then in terms of the y values, I don't have any y's in my red equation. What do I have? I have a. So these are areas that I'm thinking of. What's the smallest area you might ever see? 0. How big could it get? Well, I don't know. That's the goal of this question, is to find the maximum area out of all these windows. I'll leave it at 10, and if I need to change it, I will. You could do some work to maybe guess like what the area might be, but let's just try that. What did you see? Did you see it? It shot way off the screen. Oh, but it did come down, and it came down someplace less than 15. Okay, we just have to find it up there. Some people like to go from 10 to 20. I don't like to do that. I add zeros at the end. If 100 doesn't work, what's the next number I'm trying? 1,000. Add zeros. It's a lot faster than going 10 at a time. Okay, there's the top. You guys can see, again, this horizontal. This horizontal here is the radius. This vertical here is the area. You can see if you have a very small radius, you don't have much area. If you make a radius bigger, 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 the area gets bigger, bigger, bigger until you reach some maximum point. And then all of a sudden your radius is so big that you got smaller and smaller areas. You're making like big semicircle, but hardly any rectangle, and you're actually losing area. So we know how to find the max on the calculator. So we'll do that real quick. I think I did not type the right thing. Let's try that again. Max 4. Okay, left bound, definitely more than 0. We went up to 15. I can just say 15. The guess doesn't matter, and it will find me that top point right up there. What's the best radius to use? 4.2. Use a radius of 4.2. What is that 63? That's the area. Use a radius of 4.2. You will get the biggest area window you can with an area of 63 square meters. We were in meters the whole time here. Questions on any of that process? This problem is probably a little bit more involved than something I might give you on a test, but I wanted to do one that was challenging and involved a lot of steps. I hope that we were sort of with it the whole time as why we were doing it, because it's kind of easy to watch, but then when you have a problem in a blank piece of paper, that's really what you need to get good at to succeed on the test. So anyway, that's you'll see some practice problems. You'll see some problems like this in tonight's homework. Recognize they are challenging. There's going to be word problems. So it's okay if it doesn't go clean start to finish like this. Okay, let's go to the next page, number 3. And who's our reader now? Brian, you went? Michael? Tyler? Okay, so here's a table. Looking at the number of women in the workforce, what can you say? Increasing. Okay, we can look at the numbers and decide that it's increasing. Can you know, looking at the numbers, if maybe, so I'm thinking about time as my horizontal, and then this is the number of women that are in the workforce. Looking at the numbers, just looking at the table, can you tell if maybe it's like a linear, like it's increasing? Can you know that it's linear by looking at those numbers? Not without doing work. It'd be a whole lot better to get it so that we can like actually see the dots. So we did all this stuff before. Let's refresh our memories here. Okay, first thing we're going to do you guys remember where we find the place to enter all the data? It's not list, but you're close. Stat. So hit the button that says stat. I have calculators here. Does anybody need one? All right, so just bring up an ID card. Thank you. Just put it down. There you go. Anybody else need one? There we go. I'm going to give that to you as well. Okay, so inside of stat, we type in all the data. Oh, I probably should have said this. We're going to go years from 1900. So that first number should be what? 10. Okay, so once we've typed in the data, we're going to go into y equals. First, clear anything that you have typed in there. And if you want to put the scatter plot on, easiest way is to just go up to highlight plot 1, and then push enter, and you can see it's now solid. Now, there is a chance that your plot 1 is not set to the default, so we won't see what we're supposed to see, but I'll come around and take a look at it in a second. If you want to actually see the plot, so if you hit graph on the standard window, zoom 6, you're not going to see a whole heck of a lot because the standard window isn't appropriate for these dots. But do you guys remember the calculator is actually pretty good at finding a good window for dots? If you go down to number 9, you see zoom stat. So if we all hit 9 or enter right there, we should see those dots. Is there anybody who does not see those dots? Good. Did we see the dots? So do zoom and then number 9. You don't have to type it in, it'll just automatically hit enter. One thing you have to do is go up there and push up and hit enter to turn that on. Now we'll go zoom 9. There they are. Only for dots. Yeah. So you have to go up here, hit the up arrow, and then hit enter. Now do zoom stat. Zoom 9. There they are. Some of those look not quite right, but okay. What do we think? Straight line, is it good? Doesn't quite look linear to me. It looks like it's kind of growing slow in the beginning and then faster. So what does that mean? It means that there's an increasing number of women in the workforce, but it took kind of a while before the growth was quick, right? As it became more commonplace for women to be in the workforce and not in the home. I think that's what we're seeing here. Like back in here, this is the early 1900s. Not a lot of women in the labor force, but then it becomes common, it becomes accepted for women to leave the home and be in the workforce. And you can see that line, the thing here is going up faster and faster. Well, okay, let's go ahead and find the best fit line just to remind ourselves of how we do that. So from the main screen here, anybody remember where we see the linreg command, linear regression? So we go back into stat. Vars is here at some place. But everybody hit stat, we see this. We go right to the calc menu. We're looking for linear regression. It's number 4. Now you could hit enter right there, and it will find you the equation of the best fit line, but I would like to see it graphed. So we have to do a little more work if we want to see it graphed. This is where we have to tell the calculator, put the answer in Y1. That's what I need to put right there. Where do we find Y1? This is inside of vars. So the vars button is right over here. Hit vars. Still have to keep hunting. Where is it? We'll go to yvars. And the very first thing, function. Finally, our list of where we can put it. That was a lot of buttons. If you missed one, you probably missed the last few. Check with your neighbors. Make sure everybody's got this command Help them if they don't. You hit enter. It tells you the equation of the best fit line. It turns out it's 0.68x plus negative 7.8. That's the equation. And if I hit graph, it will draw it for me. Good or not so good? Yeah, let's look at the R. Really, R squared is what I'm interested in. 0.91, it's reasonable, not super. It's okay. You have to, I'll come over and do it. You just have to do it once. Yep. Okay, so here's what we're going to do. We're going to find something better. Could you guys imagine those dots, but connecting them with something more complicated than a line, but which might fit better? A curve. Let's think of the simplest curve we've talked about this year. What's the simplest curve we did? Like an x squared, like a parabola. You guys buy that maybe there's a parabola that comes in, and hits, and then maybe it's on its way up off the calculator? Okay, let's find the best parabola. It's in the same place as linreg. Again, where is that? We're going to stat. Where did we find linreg? It was over in calc. And we're looking for a parabola. You see which one says parabola without saying parabola? Is that quadreg? Because you guys know that quadratics are the parabola graphs. So we hit quadreg. Don't hit enter. Everybody have this command? What do you think I want you to put over there? Yeah, I'm going to actually put y2 so I can see them both, but I want to put it somewhere. So you got to find the y's again. That's inside of vars. To the right. Function. You can put it on your index card if you want to bring it to the quiz. Yep. And I'm going to put it in y2. If you put it in y1, it's fine. It's just going to erase the line that we had there before. I'll put it in y2. Check with your neighbors. If they don't have this command and you don't know how to find it, help them. Yeah, this is the ending part. So what you want to do is second enter. I'm going to ask it for that command again, but I'm going to put something at the end. Comma, go into vars, scroll to the right, hit enter. This is a list of where you can put it. Hit enter again. Now hit enter. This screen will look the same once it's finished, but there it is. Okay, so we do our quadratic regression. Looks different. It used to be you had A, B, R squared, and R. What do we have now? We have A, B, C. What are we missing? R. Turns out R is only defined for lines. You're not going to see R for anything else, but you'll see R squared. Okay, so that's our equation. If you hit graph, yeah, and the R squared was a real good number there. So there's our line, and here's our parabola. Oh, that's pretty good, right? It goes dead center through some of them, and the ones it misses doesn't miss very much. Okay, and then Eliza wants to think about R squared. Why is R squared equals 0.997 good? Really close to 1. It used to be 0.90 for the line. Okay, so let's see if we can't start filling in some of the blanks here. We're going to skip past the equation of the regression line because we've done that before. I want us to write the equation of the regression parabola. So we're just going to grab that off of this screen right here. We just need to know what we're looking for. I tell you the format of the equation at the top. Ax squared plus bx plus c. How much is a? 0.008. We're just going to go to the nearest 1,000 each time. So you're going to copy that equation, but you're going to put these numbers all to the nearest 1,000. I'm going to go ahead and take a screenshot, and then I'll write my equation. Okay, so the equation here, y equals, it says ax squared. What do I put? 008x squared plus bx. What do I put? Plus c plus yeah, the c represents the y-intercept. Just like that's the mx plus b is the y-intercept. It's, yeah, whatever number is sitting at the end is always the y-intercept. Okay, that's our parabola. Any questions on that? Ben? I'll come over and fix it. Yeah, no problem. Okay, let's see if we can answer part C here. We'll go back to Ben. Ben, can you read C? Okay, so the whole point of getting this equation isn't to just look at a pretty curve and say, well, it's close to the dots. It's to use it to predict. Okay, we're predicting something in the past, but let's try it anyway. How much is X if we're in 2009? X is 109, right? If we're at 2009, that's 109 years from 1900. So what we need to do is we need to put in 109 in for all those X's. That's because we're talking about 2009. Yeah. Everybody understand why plugging in 109 is going to give us our estimate of women in the workforce? Does everyone agree typing in 109 in that equation is annoying? Yeah, there's a whole lot. There's a better way to do this than to retype it all. First of all, retyping it is annoying. Second of all, we rounded, right? You could introduce some pretty significant error by typing in rounded numbers instead of letting the calculator do its thing with the most accurate answers it can do. So better than typing all that stuff in is to come over here and say, okay, what was the name of our parabola? Which one is the parabola? Is the y2. So if I can just ask the calculator to find y2, then I've got it. Where do I find y2? It's the same place it was before. It's in vars. Go to vars. Go to y-vars. Hit enter and then select y2 because that's where our parabola is. This is the y2 function. Think of it like an f of x. What's the x for this example? Is 109. This is my way of asking the calculator to find the value of y when x is 109. It's exactly what I want. It's a whole lot easier to do that than to type all this in again. It's also more accurate. So how many women working in the workforce in 2009? About 81 million. Did anybody do the retype thing in red? What's the answer? What do you think? The right answer is 81. The answer typing it in again, which is annoying, is 79.2. We're off by 2 million. That seems like pretty significant rounding error. It's 2 million women that we are wrong by. Okay, so I think there's a compelling reason to know how to do it this way. Okay, in reality, if you look at this last sentence here, according to that website, there were 72 million women working in 2009. So 81.5, it's off by a little bit. Questions on this? All right, let's go to Joe for number 5. All right, so we're going to skip over 6. It's just general guidelines. We're skipping over 7, more general guidelines. You guys are going to do this polynomial regression. There are 3 problems for you to tackle. If you kind of partner up, then maybe you can help each other and make sure we're all typing the same thing. If you missed any of the steps, you'll find it on the page after. This how to perform polynomial regression. That has all the commands laid out, okay? So partner up and see how far you guys can get on those three. And we're going to go until about 155 on this, and then we'll start the next thing. Okay, so the last thing I want to say about this regression stuff, if you didn't get to number 3, just try it later on. But the last thing I want to say is, for example, on number 2, this is what the data looks like. So hopefully we've seen this recently. And you might ask yourself, you know, like, is it a parabola or is it a cubic? And do you just have to do trial and error? Well, if you have a good picture in front of you, I don't think you need to do trial and error. If I'm looking at this graph, in my mind, I'm kind of imagining something that goes up and then comes down and then goes up, and maybe it's coming down again. That's what I see, just trying to like visualize what this might look like if I connected it with some smooth curve. So here's the question. How many turning points does it have? Up, and then down, and then up, and then down. It looks like about 3 turning points. Maybe something up here in the top, then maybe a bottom, and then another top as it's on its way back down. If it's got 3 turning points, you guys remember we had this fancy little theorem that said if you know what the degree is, you subtract 1 to get the number of turning points. Like if our degree is 5 turning points, probably 4. If the number of turning points is 3, then what do you think the degree was? Probably was 4. So instead of like a trial and error, I'm just looking very clearly for something quartic. That's degree 4, right? So we've got our quadratic is degree 2, cubic is 3, quartic is 4. Maybe some of you guys were adventurous and explored beyond. I don't know why there's a second lin reg. It's a copy of the first one. The letters are changed a little bit. I don't know why it's there. ln, we're going to see that symbol, but does anybody know what ln stands for? It looks like another lin, but ln actually stands for 2 words. And it's okay if we haven't seen it before, but when I say it, I bet some of you have seen it. It stands for natural log, or natural logarithm. There's a button over here on the far left that says ln. It's the same thing. We'll talk about that in detail together. Then there's this thing which says exp. What do you think? Is that a Microsoft product? No? Exponential, that's what exp stands for. We will talk about those. Then there's a PWR, power function, whatever that is. And then down here, logistic, whatever that is. So there's a bunch of options. And then finally, if you get to the bottom, you've made a sin. So they want you to stay up. Katrina smirked a little bit. I got a tiny, tiny little smile. So that's a sign regression, whatever that is. So so it felt like quartic was the best one here, just thinking about number of turning points. And so if you do that, you can maybe sort of quickly get a good sense of what a match might be. Notice it takes a lot longer to do that than the linear. Let's see, do I have a good R? 0.985, that's pretty good. And if you look at the picture, it should come darn close to all these points. Okay, any questions on that? All right. Let's go to here, page 34. Okay, just to be clear, the homework assignment is what's up above. We're not assigning any more homework besides what's the normal assignment up there. There is a quiz. We have just finished the material for the quiz. It's everything up until that moment right there. But because we have a quiz and because the next section is kind of long, we're going to grab these 10 minutes now and start what I was planning on doing Friday. So let's go to number 1. I think we are up to surge. Okay, let's try part A. List the solutions of P of X equals 0. We did all this last time, but we're just reminding ourselves. So instead of P of X, what am I putting? Putting 0 right there. Can you guys see the solutions? What value of X will make this part equal to 0? 5. And so you can just grab them one at a time. What's the next one? 10 and then 2, -7. Those are all the solutions to P of X equals 0. And again, Michael had asked that question because we ignore something. What did we ignore? The point 0.005. Is it ever equal to 0? No, so it doesn't give us any more solutions. Okay, then it says list the zeros. We defined that word last time, but I will remind you that the zeros of P are the values of X that make P of X equal what? Equal 0. That's what the word 0 means. It means find the X values that make the whole thing equal 0. Well, that should look really familiar because that's what part A is, right? Same answers. 5, 10, 2, -3, -7. Okay, part C. X-intercepts, looking at the picture. What's the far left one that you see? Over there, it looks like -7. The next one is -3, and we see same numbers again. Just one little detail, x-intercepts technically are points, so they should have two numbers, -7, 0. Okay, and then finally the factors. This word factor, what operation does it correspond to? It's multiplication. Anytime you hear the word factor, it means there's multiplication lurking around. For example, what are the factors of 35? 5 and 7, right? Because 5 times 7 is 35. You see the word factor, it means there's a multiply happening. What if I said this? Factor x squared minus 4x. What can you take out of both? X. What's left? X minus 4. What operation is between? Multiplication. I say factor, I mean turn it into multiplication. Every time we say that word. Okay, so then the factors of this guy right up here, the original thing, factors of this are just all the things that are being multiplied together, like 7 times 5. Those are my factors. What's the first factor? It's in yellow. You could put 0.005 in the front. It's not going to matter to us, so I'm not going to put it. Probably technically it is a factor. But what I'd really like to list here is x minus 5 is one factor of the thing. And I'm going to put a comma because I'm listing. What's another factor? X minus 10. It seems like silly to just write it down, right? We're not doing anything. We are. We're learning some of this vocabulary stuff. Okay, there are 4 things that we just did in this question. We found solutions to that equation equals 0. We found the zeros of a polynomial. We found the x-intercepts of the graph. And we found the factors. And we're going to bring them all together down here in number 2 with the factor theorem. Megan? Let's pause right there. Which part was that? That's part A. We solved P of X equals 0. We found 5 numbers. Keep going, Megan. Okay, which part was that? That was B, where we found the zeros. Go ahead. Where did we do that? Part C, x-intercepts. And go ahead. Okay, where did we do that? B. Nice, A, B, C, D. I lined it all up for you guys. I could have mixed it up. Okay, so let's bring it all together. Eliza, number 3. Okay, that is our big summary. Stay on this page for just a second. But that's what the factor theorem says. It says all 4 of these problems are really the same problem, okay? Which means that if I ask you to solve one of these problems and it seems difficult, then maybe just reframe it as one of the other ones if that's easier. Yes? Maybe answering one of those is easier than another depending on what I give you. So forget the question that I'm asking, answer the easiest version that you can find. Okay, so the one reason I wanted to stay on this page for a second is this guy right here says x minus c. So that's going to be really common, and it's going to be really easy to make a mistake. If I tell you that 2 is a 0 of p, then what factor am I talking about? The factor is x minus 2. Always x minus. You start with 2 that came from x minus 2. Isn't that what we saw up above? I'm talking about this one right here. What value of x made that 0? Positive 2. It looks like negative 2 in there, but you know that when you solve it, it changes the sign. So if I tell you x equals 2 is important to me, then you're thinking x minus 2 must have been up there. If I change it to something that wasn't in this guy, what if I say that p of 12 is equal to 0? Can you guys write down what factor must be inside of p somewhere? Everybody agree? If p of 12 equals 0, that's like this part A. If you find a number that makes it 0, then x minus that number must have been a factor. X minus 12 must be a factor. What if it was a different sign? What if I said p of negative 8, 0? Can you guys write down the factor that must be in there somewhere? What factor is in there? It's x plus 8. It's x minus that number in the parentheses. Okay? Whatever value of x makes the thing 0, it's always x minus that thing that's a factor. Okay, let's take a look at this. Number 4. Connor. Okay, so here's the question. Is that polynomial equal to x minus 2 times some stuff? That's what I'd like to know. If it is, then is x minus 2 a factor? Yes, that's what it means to be a factor. It means you have multiplication. Is that easy to know if x minus 2? Not in that form, right? We don't have any idea at the moment how to take x cubed minus x squared and break it down into factors. Eliza? Okay, so is there a 0 at x equals 2? That is the question. And so you can graph the thing, and maybe you're looking for an x-intercept at x equals 2, and if you find one, wonderful. This is reframing the question. What's the other alternative? Is p of 2 equal to 0? That's the question. Is that easy or hard to figure out if p of 2 is 0? Pretty easy. Plug in x equals 2. You're either going to get 0 or you're not. Can we just get an answer and then we'll call it a day? So plugging 2 into all that stuff. What's it equal to? It's equal to 4. Was it equal to 0? No. Is x minus 2 a factor? No. Without doing any factoring, we can know it is definitely not a factor. And that's a whole lot easier than what we're going to see with the rest of this stuff on Friday. See you then.